The nice part about problem number 10, when we have to find the value of x in each of the following diagrams, is we've got a similarity statement. It tells us figure ABCD is similar to figure EFGH. And be careful here about the orientation, because just be careful with the orientation of the figures. Because when we set this up here, if we start with AB, well, AB is similar to EF. So AB has a length of 14, and EF has a value of x plus 5. Then we can do BC. Well, BC has a value of 16, and BC is going to line up with FG, and we don't know what the length of FG is. So that's not going to help us much. But again, you have to watch out for the orientation of the two figures. We can look at CD here, but CD, we don't know that length. We don't know anything about it. But CD lines up with GH, and we don't know anything about GH either. And in fact, I'm going to erase that completely because it's not going to help us. And neither is that other, the 16 over the FG. But then the last that we can put together here is we can take AD, which has a length of 10, and EH has a length of x minus 3. So watch out and make sure that these align. Again, this one doesn't help us. But once we take this, 14 over x plus 5, and 10 over x minus 3, that will allow us to solve this problem. And now what we're going to do is we're going to have to cross multiply it. But don't forget that we need to distribute when we do this problem here. So this is going to become 14 times x minus 3. And it's going to become x plus 5 times 10. And we need to distribute both the 14 and the 10. When we distribute, we get 14x minus 42 equals 10x plus 50. Solve it the way your Algebra 1 teacher taught you, but I'm going to move my letter to the left. So we're going to subtract 10x from both sides. And we're going to end up with 4x minus 42 equals 50. And now we need to move the 42 to the other side. So we're going to add 42 to both sides. And we get 4x equals 92. And then to finish here, to figure out the value of x, we're going to divide both sides by 4. And 92 divided by 4 is 23. So we look at letter B. Again, it's nice. We've got this statement of similarity. Triangle ABC is similar to triangle EDC. So when we look at this here, again, if nothing else, a good reminder is that those two angles are vertical. I don't think that it's really going to help us in this problem, just as an aside there. But if we look at this, I'll try not to set up any extra there because I'm trying not to be confusing. But if we start here, AB, well, we don't know anything about AB. But AB lines up to EB, and we don't know anything about EB. But what we do know is across from our right angle, we've got a value of x plus 7. And in our other triangle, across from that right angle, we've got the value of 12 minus x. So now, when we take a look at the other piece of this, we've got to go down to the triangle ABC, because that's the triangle that has x plus 7 in it, it has a value of 4, which is BC. That's the second and the third piece. So our second and our third piece in our other triangle, DC, has a value of 6. And once again, when we solve this proportion, we're going to cross multiply. And it's going to require distributive property. And we get x plus 7 times 6 equals 12 minus x times 4. By the way, it doesn't matter if you put the 6 out in front of the parentheses or the 4 out in front of the parentheses. We're still going to have to distribute. And what we end up with is 6x plus 42 equals 48 minus 4x. And again, solve it the way your Algebra 1 teacher taught you. And add 4x to both sides. And we end up with 10x plus 42 equals 48. And then we can subtract 42 from both sides. So we end up with 10x equals 6. And divide both sides by 10. So we end up with x equals 6